Now next question is, if 2 by 11 is the probability of an event, what is the probability of event not A? This is probability of an event A. What is probability of not A? So here probability of A is 2 by 11. So probability of not A, that means P of A dash, this can also be denoted as P of A dash. So it is equal to 1 minus probability of A. So it is 1 minus 2 by 11, so 9 by 11. Now in this question, in a lottery, a person chooses 6 different numbers at random from 1 to 20. Person chooses 6 different numbers at random from 1 to 20, and if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize? When any 6 numbers are chosen from given 20 numbers, then total number of choosing 6 different numbers, 6 different numbers from 1 to 20. From these 20 numbers, any 6 different numbers can be chosen by 26 ways. So 6 different numbers from 1 to 20 can be, total number of choosing 6 different numbers from 1 to 20 is, we say total number of such selection n is equal to, there are 20 numbers, select any 6. So this is calculating this n, 20 is 620 into 19 into 18 into 17 into 16 into 15, 6 steps back, 1 2 3 4 5 6 upon 6 into 5 into 4 into 3 into 2 into 1. So here 5 into 3 15, 4 into 5 20, 2 into 8 16, 6 into 3 18. So this is 5 into 19 into 3 into 17 into 8 is left. These numbers are left. So calculating this by calculator, this product is 38760. So sample space contains 38,760 such selections. If you select any 6 different numbers from first 20 natural numbers, then total number of selections 38,760. Now, to win the lottery, particular 6 numbers must be obtained. If particular fixed 6 numbers are obtained, then that person can win a lottery. So to win a lottery, which event must appear, which event must occur? Event of getting fixed 6 numbers event of getting fixed fixed numbers is required. And there is one and only one such group of fixed 6 numbers for winning prize. So here R is equal to, this event contains only one number. So event contains, therefore event contains R equal to one outcome. This event contains only one outcome. There is such only one group of 6 numbers. So required probability is R upon n. So 1 upon 38760, 1 upon 38,760. Now in this question, probability of A is 0.35, probability of A intersection B is 0.25, probability of A union B is 0.7. What is probability of B? Now we know the result. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This result we know. Now putting values, probability of A union B is 0.7, probability of A is 0.35. This number is required. Probability of A intersection B is 0.25. So therefore probability of B is 0.7 minus 0.35 plus 0.25. So probability of B is 0.7 minus 0.35, that is plus 0.35, 0.35 plus 0.25, that is 0.6. So this is required probability. A fair coin is tossed 4 times and a person win ₹1 for each head and lost ₹1.5 for each tail that turns up. From the sample space, calculate how many different amounts of money you can have after 4 tosses and the probability of having each of these amounts. See here, a coin is tossed 4 times. So total number of outcomes in sample space is 2:4. That is 16. If coin is tossed 3 times, outcomes are 8. Here coin is tossed 4 times. So total 16 outcomes. Now see how to prepare list of this 16 outcomes without missing anyone. So remember trick. We know how to put list of elements when a coin is tossed 3 times. So if a coin is tossed 3 times, then outputs are HHH, HHH. Now here I keep space for 4th outcome. We are tossing here 4 times. But to put list of outcomes related to this experiment, first put list of outcomes related to experiment of tossing 3 coin. So HHH, then I keep here HHT, then HTH, then THH, then TTT, then TTH, then THT, then HTT. 3 times H, 3 times T, here 2 times H, here 2 times T. So these are 8 outputs when a coin is tossed 3 times. Now we are coming on 4 time. So we need 16 elements. So the trick is here, this 2 lines repeat again. I am repeating again. HHH, HHT, HTH, THH, TTT, TTH, THT, HTT. So these 2 lines are again repeated. Now in first 2 line, in 4th place, join H. Say here H, 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 H. Now in repeated 2 lines, join T. So T, 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 and close the set. So these are 16 outcomes related with this experiment. Now we are putting different events. Event of getting no T. Say here, I am putting events. Event E, let me say event A, event of getting no tail. Event of getting no tail. Event of getting no tail is A. So no tail, that is all times H. So H, H, H. This is the event of getting no tail. See, question is, calculate how many different amounts of money you can have after 4 tosses and the probability of having each of these amounts. So when this event occurs, when E occurs, when event E occurs, winning amount is here, winning amount is on every head person wins ₹1. So 4 times H, that is 4 into 1 rupee. So that is 4 rupees. Person wins ₹4. Now let me take event. So now say here, probability of this event. Here S contains 16 elements and here A contains 1 element. So A contains 1 element. So what we say? Probability of event A is 1 by 16. So probability of event A is 1 by 16. And when this event occurs, when A occurs, person wins ₹4. So probability of winning 4 rupees, 4 rupees is 1 by 16. So that is case 1. Now case 2. Suppose B is the event of getting 1 tail. B is the event of getting 1 tail. So let me put event B. Now 1 tail. So say here 1 tail, 1, 2, 3, then here two tail, here two tail, here two tail, here again one tail, then say here three tail, two tail, three tail. So 1, 2, 3, 4. These 4 elements are containing one tail. These 4 outcomes, when this occurs, we get one tail. So B is event H H T H H T H H T H H H H H H T H H H T. So this is the event of getting one tail. Now probability of B, here B contains 1, 2, 3, 4 elements, and when B occurs, winning amount is, here I am adding one more statement before taking probability. When B occurs, winning amount is see on 3 head, on each head person is winning 1 rupee. So on 3 head person is winning 1 rupee, plus on one tail he is losing 1.5 rupees, that is minus 1.5. So 1 into minus 1.5. So this is 3 minus 1.5. So 1.5 rupees. Now here B contains 4 elements. So probability of B is 4 upon 16, that is 1 by 4. Probability of B is 1 by 4. So when B occurs, then person wins 1.5 rupees. So probability of winning 1.5 rupees. Therefore, probability of winning 1.5 rupees is 1 by 4. Then third, let me say C is the event of getting 2 tails. Here no tail, 1 tail, now 2 tail. In no tail this is taken. Now C is event, let me put element 2 tails. Say here there are 3 tail, here 2 tails. So we are taking this element TTHH, THTH, HTTH, HHTT, HTHT, THHT, then it's over. So these are 6 outcomes in which there are 2 tails. So C contains 1, 2, 3, 4, 5, 6 elements. 6 elements. So probability of C is 6 by 16. Now when C occurs, when this event occurs, winning amount is, see, winning amount is, there are 2H 2T. So on 2H he is winning 1 rupee, plus on 2 tail he is losing minus 1.5 rupee. So loss of 1.5 rupee on 2 tail, on 2 head 1 rupee. So 2 into 1 2 minus 3. So that is 2 minus 3, that is minus 1 rupees. So loss of 1 rupee. Therefore, probability of losing 1 rupee, probability of loss of 1 rupees is, that is equal to probability of C. So probability of C here, so probability of C is 6 by 16, that is 3 by 8. Therefore, probability of loss of 1 rupee is 3 by 8. So when event C occurs, person loss 1 rupee. So probability of event C, that is same as probability of loss of 1 rupee. Now fourth case, say here no tail, then 1 tail, then 2 tail. Now I am taking 3 tail. D is the event of getting 3 tail. So we put elements in D, 3 tails, that is, say here there is no 3 tail. Say here this is 3 tail, T T T H, then here T T H T, then T H T T, then H T T T. So D contains 4 elements. So here 4 elements. Now when D occurs, winning amount is, winning amount is 1H, on 1H 1 rupee, and on 3 tail minus 1.5 rupees. So that is 1 minus 4.5, that is minus 3.5 rupees. So that is loss. So probability of D, here probability of D is, D contains 4 elements, total here 16 elements. Probability of D is 1 by 4. When this event occurs, its probability is 1 by 4. Therefore, if this event occurs, person wins minus 3.5 rupees. That means he loses 3.5 rupees. So probability of loss of 3.5 rupees is 1 by 4. Now last case, event of getting 4 tail. Say here I was making underline, now only this is left, 4 tail. So case number 5, let event E, it is the event of getting 4 tails. So E is the event of getting this element. So here E contains one element. So here there is only one element. Probability of E is equal to 1 by 16. And when E occurs, winning amount is 4 times T. So 4 times E is winning minus 1.5 rupees. So that is minus 6 rupees. So loss of 6 rupees. Therefore, probability of loss of 6 rupees is 1 by 16. So when this event occurs, player lost 6 rupees. So probability of this event, that is equal to probability of losing 6 rupees. Next question. If E and F are events such that probability of E is 1 by 4, probability of F is 1 by 2, and probability of E and F, that means E intersection F, it is 1 by 8. We want probability of E or F. Probability of E or F, that means probability of E union F. Now probability of E union F is P of E plus P of F minus P of A intersection F. So putting values, P of E, it is given 1 by 4, P of F is 1 by 2, P of E intersection F is 1 by 8. So here LCM is 8, this is 2 plus 4 minus 1. So it is 5 by 8. So probability of E or F is 5 by 8. Second is probability of not E and not F. Probability of not E and not F, that means E dash, and means intersection, not F, that is F dash. P of E dash and means intersection, not F, that is F dash. So this is now by De Morgan's law, this can be expressed as E union F whole dash. Now probability of any event A dash, probability of A dash is 1 minus P of A. P of A dash is 1 minus P of A. Now value of this is given. Probability of, say, this is already here found. P of E union F. We have found 5 by 8. So we will put here 5 by 8. So this is 3 by 8. Now in this question, here given that probability of not E or not F is 0.25. State whether E and F are mutually exclusive. So this means probability of not E, that is E dash, or means union, not F, that is F dash. So not E or not F, that is F dash, it is 0.25. Now by De Morgan this can be expressed as E intersection F whole dash Now P of A dash, P of A dash is 1 minus P of A. So this means probability of E intersection F is 0.75, and this is non-zero. That means probability of E intersection F is not zero. Therefore, this event is not impossible event. This is not impossible event. If probability is zero, then event is impossible, but this is non-zero, so event is not impossible. And if intersection of two event is non-empty, then these events are not mutually exclusive. This is non-empty, so E and F are not mutually exclusive. If probability is zero, then that event is empty, then both events are said to be mutually exclusive. But here, because of probability non-zero, it is non-empty, so E and F are not mutually exclusive events. In class 11 of a school, 40% of students study mathematics and 30% students study biology. 10% of students study both mathematics and biology. If a student is selected at random from the class, find the probability that he will be studying mathematics or biology. Or this can also be asked by this way, that find the probability that he will be studying at least one subject. So say, sometimes in question, instead of word or, event A or B, this word at least one of the event, it can be given. So probability of occurrence of at least one event or probability of A or B, so meaning is same. Now see, here we suppose A be the event. We suppose A be the event that student study mathematics. Selected student study mathematics, that is event A. A student is selected. One student is selected. If a student studies mathematics, that is A occurs. If student studies biology, event that students study biology, then B occurs. This is a random experiment. Select a student, ask him which subject he is studying. If answer is maths, that means event A occurs. If answer is biology, that means event B occurs. Now we are given that probability of this event, information given, 40% of students study maths, means out of 100, 40 are studying mathematics. So probability of event A is 40 by 100, so that is 0.4. Say in mathematics, we can say instead of a possibility, say many values in mathematics are given in percentage. So if anything is given in percentage, then that value can be spoken in probability also. 40 percentage, that means probability is 0.4. In percentage, we take base of 100. In probability, we take base of 1 out of 1, 0.4. So it's nothing but 40%. So that is 0.4. Then probability that student studies biology. 30% students are studying biology. So 30 by 100, that is 0.3. 10% students study both. That means maths and bio 10%. That is 0.1. Now we want probability that student will be studying maths or biology, or in other words, at least one subject. Probability that student will be studying maths or biology, that means at least one subject. So remember, when at least word is given, that is substitute for or. So probability of this event is, this is probability of A union B. So in this case, at least word given or given, we use union. And by result, it is P of A plus P of B minus P of A intersection B. Now probability of A is 0.4. Probability of B is 0.3. And this is 0.1. So it is 0.6. So this is required probability. The probability that a student will pass the final exam in both English and Hindi is 0.5, and probability of passing neither is 0.1. If probability of passing the English exam is 0.75, what is the probability of passing Hindi examination? So here there are two events. A selected student is passing English exam, or selected student is passing Hindi exam. So let me denote them by symbols. Let A be the event that a student will pass English exam. B is the event that a student will pass Hindi exam. So question of two events. Now given that student will pass final exam in both, that is A intersection B. Probability of A intersection B is 0.5. Probability of A intersection B is 0.5. Probability of passing neither is 0.1. Probability of passing neither is not A and not B is 0.1. Not A and not B, not English, not Hindi, not passing English and not passing Hindi. If probability of passing the English exam, that is probability of A, is 0.75, what is the probability of passing Hindi exam? So probability of B is required. So see, to find the probability of B, we shall use this formula. P of A union B is P of A plus P of B minus P of A intersection B. Now see, this value is given, this is given, P of A is given, this value is required. So to find this value, still we need one more value, probability of A union B, and that value can be found from this expression. So now taking this value, P of A dash intersection B dash is 0.1. So from this value, P of A dash intersection B dash 0.1, that means probability of A union B whole dash is 0.1. Therefore, probability of A union B whole dash, that is 1 minus P of A union B, 0.1. P of E dash is 1 minus P of E. So probability of A union B is 0.9. So this value now we are using here. So now in this formula, putting values, this is 0.9 equal to P of A is 0.75, this is required, and P of A intersection B is 0.5. So therefore probability of B is 0.9 minus 0.75 plus 0.5. So probability of B is 0.9 minus 0.75, 0.15. 0.15 plus 0.5 is 0.65. So probability of passing Hindi examination, probability of passing Hindi examination is 0.65. In a class of 60 students, 30 opted for NCC, 32 opted for NSS, and 24 opted for both NCC and NSS. If one of these students is selected at random, find the probability that the student opted for NCC or NSS, student has opted neither NCC nor NSS, the student has opted NSS but not NCC. So let me assume two events. Let A be the event that selected student opted for NSS, and B is the event that selected student opted for NCC. So say here 30 opted NCC, first word we put here NCC, then second is NSS, changing order of these words. So event A for NCC, then event B for NSS. Now see values. Here, probability of A. See, out of 60 students, 30 opted NCC. Out of 60, 30 opted NCC. So 30 by 60. Probability of B. 32 opted NSS. So probability of B, 32 out of 60. So 32 by 60. Probability that 24 opted both NCC and NSS. So both, that is A intersection B, 24 upon 60. So here out of 60 a student is selected. So that's why divide by 60. One student is selected. So this is 1 by 2, or keep as it is. Let me keep 60 as it is. For convenience in calculation, we keep these values as it is. Now first question is probability that student opted both NCC or opted for NCC or NSS. So probability that student opted for NCC or NSS is P of, it is A union B. So that is P of A plus P of B minus P of A intersection B. So here these values, putting values 30 by 60 plus 32 by 60 minus 24 by 60. So this is equal to 30 plus 32 is 62. 62 minus 24 is 38 by 60. So this is 19 by 30. So this is required probability. Second question is probability that student has opted neither NCC nor NSS. Probability that student has opted neither NCC nor NSS, and it is probability of neither NCC means not A and not B, not A and not B. So by De Morgan, it is P of A union B whole dash. So this is 1 minus P of A union B. Probability of E dash is 1 minus P of E. So this is 1 minus 19 by 30. So this is 11 by 30. Third is the student has opted NSS but not NCC. So probability that student has opted NSS but not NCC, NSS but not NCC, NSS yes, NCC no. So B but not A. So that is probability that B but not A. B is for NSS. So opted NSS but not NCC means not A. So keep dash over A. So not A and B. So this is P of B minus P of A intersection B. Now probability of B is 32 by 60 minus probability of intersection is 24 by 60. So this is 12 32 minus 24, that is 8. 8 by 60, that is 2 by 15. So it is required probability.